my name is Zhikai, and I'm from RTI. So for those that don't know, RTI is actually a vendor of DDS. How many of you heard DDS before? I'm sure in ROS. Okay, yeah, because DDS actually used under ROS itself. So yeah, we're actually a commercial company that actually sells a commercial version of DDS, which means, license fee and stuff like that. So yeah, actually like a month ago, my company asked, to give a talk at this event. And to be honest, I was a bit worried because, everyone is, are you serious? Yeah, we are a commercial company and coming to give a talk at a, place where everyone is, so passionate about open source. So, I was a bit worried. I even had images like, have you seen those old Western movies where there are a few guys with a cowboy's hat sitting at the bar counter and someone clearly out of town, walks inside and they're looking at him. What are you doing here? Stuff like that. Yeah, but, yesterday, I talked to some of the guys here, even people from the ARTC, ROS-I have been very, welcoming and, friendly about everything. So I realized that actually it's really something wrong with my thinking. I shouldn't be thinking like that. Because actually, at the end of the day, whether is it, open source or commercial or whatever, I think we're all here for a common goal, which is actually, to advance the state of robotics and also actually to really solve real-life challenges. There's a challenge out there, some of you talk about, early on you talk about, it depends on the technology is actually to solve a certain challenge. So we actually have to look at whatever challenge is out there to solve and, focus on the technology first. Whatever else is out there, we can, think about later. So today's talk is actually more about the technical side of stuff. So I think all of you heard of DDS before, but not all of you all might have a lot of detailed experience about it. So maybe today I'll share a little bit more about what DDS is and how it's actually used in, in the industry in, many systems. I mean, be it ROS2 or non-ROS2, just sharing this kind of information. And also maybe talk a little bit how RTI actually helps to, is planning to actually advance some of the DDS functionality in ROS2 moving forward into the future. Yep. So a little bit about me, my background is actually in communications. So I'm not really a robotics guy, so please don't ask me any questions about robotics. I probably won't be able to answer you. But I have a quite long history in communications, any kind of protocols, I'm probably familiar. If you have any questions regarding that, yeah, we can actually, I'll try to finish a bit early so we can take some QA, or we can talk about it a bit later. Yeah. Anything to do with non-technical stuff, you can look for my partner up there, which is Fanny, because I'm not dealing with that. Okay. So a little bit about RTI. So we are actually in the industry for quite some time. I would say more than 30 years. So this is actually a snapshot of all the different industries that we're actually involved in. Our biggest industry is actually in the defense sector. So I think Singapore is a small place. I'm sure a portion of you all have worked in the defense sector before, so you have seen us being used there. So we're used in a lot of, for example, US Army warships, like naval ships. So it's actually, DDS actually widely used there. And our second biggest industry is actually automotive sector. So as you know, there's a new boom of EVs out there in the market. Especially in China, in the US, a lot of startups that's actually dealing with autonomous vehicles. So yeah, DDS is actually used there quite a lot. I would say a good portion of them are running ROS2 inside. Like in China, we have a lot of customers, running ROS2. I mean, not throughout the vehicle, but of course for the autonomy stack itself. This is actually a pretty big growing industry for us. And healthcare. So we deal a lot with surgical robotics. So for example, if you search online for RTI and surgical robotics, we have a case where there was one surgical remote surgery done on the wide area network using DDS itself. So this is one area that we are involved as well. And all the other things like power plants, renewable energy, industrial automation, and we're also in the space industry here. So we actually focus a lot on production systems. And I think it's more on where the use case, there are a lot of mission critical and reliability requirements over there. So yeah, I mean, like I said, I'm not an expert in robotics, so I think you all should be more familiar than this about me. So there are a lot of requirements for advanced robotics. And when I mean advanced robotics, talking a little bit more about scalability. Like yesterday, I think during the workshop we mentioned, we are talking about tens to hundreds. I mean, maybe even more than 100 robots working together. These are the kind of advanced robotics we're actually talking about. And of course, scalability and reliability, because we are talking about operational, and you have to be reliable. If not, you're going to affect your factory floor, and it will affect, the time to actually produce the goods, and all this other stuff. A quality of service. I think you've heard it in the DDS before. It's like how the quality of how each data flow should be. Should it be reliable? Should it be a best effort? Or because each kind of data actually has a different characteristics attached to it, and you cannot ignore this fact that it's necessary, because if you don't have QoS, you probably need to build all this kind of stuff in your application layer itself. And interoperability. I mean, RMF. We have done a good job with interoperability. I think this is definitely one of the important things, because not only in the industrial automation side, but like in defense, in automotive itself, so they are all moving towards the same, route as what we are doing, which is actually to build an interoperability layer underneath, so that everything can just plug in, or based on a common data format. So I mean, all industries are actually moving towards this. So I think the work that OpenRF is doing is really great regarding this area. So but healthcare, not so much yet. We haven't really seen that movement yet, but I think along the way, it definitely will go there. So ROS-2, like I mentioned, I won't talk too much about this. The most thing I want to maybe focus on is, it adopted DDS in version 2 of the ROS-2 because of probably the history of it being deployed in production systems. So it actually has a long history, 30 over years. The specification has been there and hardened over 30 years. And also it has a lot of advanced functionality like quality of service, data-centric communication, a lot of stuff that actually makes a lot of sense to robotics applications, if you think about it. Because we're actually just talking about pushing data around. I mean, if you talk about it, your arm needs data to move. A different part, it's just about, distributing the data all around the robotic system. So they thought that DDS was a very suitable technology for it. And from version 2 onwards, they actually adopted it as a standard. This actually, I'm not sure how many of you all saw this architecture diagram before from the OMG specifications. So, yep. Okay, yep. So actually DDS has a lot of specifications inside. It consists of things like, for example, the RTPS, Real-Time Publish Subscribe Protocol. So this is the protocol that actually deals with all the things like reliability, all the different QoS like liveliness, history. This protocol actually handles all these kind of things inside. And wait, do I have a pointer here? Oh, okay. And the interesting here is actually the DDS API specification actually exposes a standardized API. So whichever DDS vendor you use, actually the API itself is standardized. So because of this, I'm sure you know that in ROS-2 you're able to change the RMW and then use different flavors of DDS, depends on your needs. So it's because of this architecture over here. It has a standard API and it actually has a standard wire protocol at the bottom, so that you can actually swap things in and out easily. And inside there, there are a lot of other specifications like security and RPC. How do you do a request reply kind of scenarios? OPCOA integration. All these are a web integration. How you actually integrate web services. All these are actually a part of the DDS specification as well. And if you go to the website here, it's open standard. It's not open source, but it's open standard, which means the specifications are all available online, and anyone can go there and take a look if you want to actually know about the details. Okay, so what are the benefits of DDS? Like I mentioned, I already did mention all of this before. So I think these are, the kind of reasons that it was chosen for ROS-2, because actually we are actually talking about deploying ROS-2 in a production environment, and it actually supports a lot of features over here that actually makes it suitable for production systems. Yep. So yeah, I think I did mention this before, so I'll skip. So one important thing in DDS is actually quality of service. Those that have used ROS-2, I mean, which is probably everyone in this room here, definitely have seen this word before. I don't know when you look at this whether you feel happy or angry or anything, but it's actually one of the big features of DDS itself. It's actually what enables it to run on many different kind of networks. Like you might have running on, a local wired network, Wi-Fi network, or we have even cases where we are running on satellite networks with very low bandwidth. So actually, these QoS are actually there to actually help. To actually help you tune the application so that it can actually work correctly on whatever environment you're actually running on. So so all these here are actually part of the standard DDS specifications. So you have things that are actually, deadline. For example, you can actually specify, a deadline for your signal. So if actually, if you have a critical signal that needs to reach between a few milliseconds, you can actually define a deadline here. And if there's anything that's missing this deadline, you can, alert the application. Reliability, like you mentioned, some messages needs to be reliable, some doesn't need, depends on your requirements as well. Things like durability, like, for example, late joining applications, if they need to actually receive data, dynamically, you can actually use this kind of QoS. So all these kind of things are actually, built to actually make an application robust, depending on, all kinds of real world situations. So DDS, actually, this is actually a strength of DDS, and if configured correctly, and I repeat myself, configured correctly, it can actually be made to run on a lot of different kind of environments over here. And over here in RTI, we do have a few, we call it vendor-specific quality of service over here. This is actually based on our years of experience with production programs, and a lot of our customers were requesting this kind of stuff. So we actually built it into our product to actually serve the needs. So for example, async publisher, we have QoS that can actually help to send large data like camera data and stuff. It helps to actually fragment the packets before sending out. A multi-channel, we can actually send different channels within the same topic to actually see where your data flow goes. And batching, if you're actually sending small samples out and you actually want to increase the throughput, we can actually batch, samples into a bigger packet to send it out to actually increase the efficiency of the communications itself. So yeah, I mean, just that's a very, very, very high level introduction to DDS for those not very familiar. I only have 20 minutes, so I can't go that deep. But after this, if you want to know more, we can actually talk further. So yeah, so in robotics, like in ROS-II, how is DDS used? So basically, DDS is actually used under the ROS-II API and RMW layer. So ROS-II actually leverages all of the features I mentioned earlier on for the communications. So for example, publish, subscribe mechanism, discovery, quality of service, and with security, even DDS secure, there's a specification there. So all these functions that are actually exposed to the application here are actually provided by DDS at the bottom. I mean, it could be our DDS, it could be another DDS, it doesn't really matter. But all these are actually provided by the DDS layer underneath. So one interesting thing I would like to say here is that if you look at it, depends on how you look at it. So if you see that this whole ROS-II framework is actually running over our API, so if you look at it from that angle, you can actually treat any ROS-II application as a normal DDS application. Okay, I mean, you could look at it the other way and say that DDS is any DDS implementation is a ROS-II application, but you've seen the optical illusion where you flip the thing around, and it depends on how you look at it, what you see. But I mean, for some situations, it's good to actually view it that way. Hey, a ROS-II application is just a normal DDS application. And with that, you actually open your world to a little bit more things. We can actually see that a lot of ROS-II applications are actually interoperable with normal DDS applications. So that's one way to actually architecture the system, if the need occurs. So yeah, so DDS plus ROS-II systems, a lot of things are listed here, and there's this thing here that maybe I'd like to elaborate a bit. So I think you know that ROS-II, I mean, has a certain set of APIs that makes DDS a lot easier to use. To be frank, it has been a good thing for us because we have got a lot of new systems based on ROS-II, this or that. But unfortunately, with the current state, what we feel is that it does limit a lot of the QoS configuration. It does restrict the use of some kind of QoS, and it actually doesn't allow the use of quite a lot of APIs. So that's why I say I'm a bit scared to come here and talk because of this kind of thing. So, but anyway, just to be clear, we're not trying to say anything. We're just saying that in RTI itself, we think that we feel that we need to do more effort to make sure that more of these functions are available in the ROS2 stack itself, like exposing more of the QoS, exposing more of the functions, and we believe that that's the way that we should go, rather than limiting a lot of the power of DDS, because in ROS2, all you get to do is publish and subscribe things and configure a little bit of the QoS, but there's a lot of rich functionality inside that has yet to be leveraged by the ROS2 framework, and we think that that's one direction that we should go. So in ROS2, for example, we have these kind of QoS over here. So a lot of the QoS functionality is not available and is not usable by the ROS2 API by default. So if we actually, like I mentioned, we think that in ROS2 we should enable more of the DDS features inside. So there's slightly more complex API. I'll say use slightly a little bit carefully, because it is a little bit more complicated to use than the default ROS2 API. But we are getting a lot of increased functionalities here, like QoS, performance, scalability, design patterns. Can actually apply a lot of the publish subscribe kind of DDS patterns to it, and you have improved operability with non-ROS systems. And yeah, I mean, there's another way. Is like, for example, there are some use cases where you might be able to extract some certain part of your system to actually run on a native DDS. We do have some examples of that, but we actually don't really think that it's a very long-term solution. It's actually just a workaround for things that are not working well at the moment. So yeah, but this option is actually there as well. Okay. So to illustrate the point a bit, we have worked with a few customers in this field, maybe not only in the factory, but in the industrial defense space, which actually have a pretty similar architecture diagram here. So so far with the limitations, we feel that this is one of good architectures that we have proposed so far. So for example, over here you will have the lowest layer, which is your AGV side, which is actually running ROS2 with a RMW layer. So this will be actually the normal stuff that we're actually doing with the autonomy stack and all the other kind of stuff which actually runs on a ROS2. And for the fleet management system, we at the moment we think that running DDS is actually one of a good choice, because are you all familiar with the concept of keys in DDS? Okay, so there's one feature, actually with this one feature, probably in ROS2, if it's fixed, I think we can solve probably most of the problems inside there, is that DDS actually supports the concept of keys. So you can think of a key like, for example, in terms of a database, you have a table and you have a key, and you can actually identify a certain object based on the key. So a table is analogous to a topic in DDS itself. So with keys, you can actually, for example, have hundreds of different robots, but they're all communicating on just one topic, because you have a key and index to actually differentiate the different robots over there. And because of that, you can actually reduce a lot of the network usage, and you can actually have fine-grained control, like which robot I want to control. I can just like in database kind of terms, you can do an SQL statement to actually filter based on the key. So all these features are actually all available in DDS itself. So just by supporting keys in ROS2, I think you actually deal with a lot of problems over there with scaling. So yep, and like what I mentioned, a DDS application is actually the same as a ROS2 application. They are interoperable. You can actually, run DDS as the backbone and run ROS2 over in the AMR. It's definitely workable. So it's not ideal. I mean, like what we say, we think that ROS2 should be running here as well. But in fact, there are things like keys that needs to be, dealt with, that needs to be put into the ROS2 specification itself. Okay, and yep, and you can actually use DDS to go back to a backend WMS, and if actually any cloud services that communicating with normal IoT platforms, you can actually use things like MQTT over there. Okay, so now I'd like to talk a little bit about what RTI is trying to do to actually try to make some improvements in this area to our RMW to actually make some of the things I talk about a little bit more workable. So we have RMW over here, which has we have makes it work with our DDS implementation itself. We can actually enable the advanced QoS configuration by XML files itself. So that means we actually, for now, we are skipping the ROS2 API, but you can actually configure all the extra functionality over there using XML. And it actually integrates with a lot of our tools and applications over here. And it actually supports our latest version as well. So this is the roadmap we're actually looking for our RMW layer. So we are actually trying to enable keys in ROS2. I mean, ideally, if it could be enabled natively in the stack, it would be good. But we are trying to do that in the RMW itself so that this functionality will be available to everyone. And we actually have a special API. This is open source, so you can actually download and play with it. You can actually access the DDS functionality directly using a special API that we actually provided. And this will actually enable easier configuration of the QoS rather than dealing with XML files and stuff like that. And we also actually looking at things like doing automatic conversion between the ROS2 topics and normal topics. ROS2 has a specific naming convention that we will actually deal with automatically in the RMW so that everything is more interoperable. And like I mentioned, keyed and unkeyed versions. So like I mentioned, this is still sort of a workaround because we are just trying to translate the unkeyed data to the keyed data that is supported there. I mean, like I mentioned, the best thing is if ROS2 could support that, that would be great. And more on interoperability will be actually we are looking to include more of this into our RMWs so that, we can do away with native DDS and, use ROS2 throughout the whole ecosystem. I think that's the main thing that we're actually looking at in the future. Yeah, we have an experimental version of this API for those who actually want to play with it. It's available on GitHub. It's still experimental, so only some of the features are there. You can actually download it and try. So I think things that are there now is like, for example, you can access the underlying DDS objects itself to actually do some of the advanced DDS functions and configurations. And you can actually access the topic, subscriber, and stuff like that if you want to actually use it. So some of our customers are actually using this already because they actually need access to some of the advanced features of DDS. So if anyone's interested, you can actually try it over here. Yeah, and we also do have gateway adapters. So we actually have this, I wouldn't say it's a product. It's actually available open source. You can actually download it as well. So this actually gives a configurable gateway from DDS to other technologies. So you can just fire up this gateway, and in XML you can actually do some configuration to do the mapping between DDS and, let's say, MQTT. Modbus, we have a plugin for Kafka as well. You just need to know all the mappings between the DDS and the different other technologies, and this gateway will do everything for you. Like I mentioned, it's actually open source over here, so you can actually download and take a look at how it's implemented. It's not shown here, but we do have a gateway for OPC UA as well. So you can just fire up the gateway and configure how you want to map the DDS topics to the OPC UA space, and the gateway will actually do everything for you. And for simulation, I think yesterday we talked a little bit about, I heard, some, we are working on simulation as well. So we do have a plugin for Unreal Engine. If any one of you are looking to look at, doing simulation using Unreal Engine, there's a plugin available where you can just plug in and then, interact with, you can grab your ROS2 data and actually use it in Unreal application over here. You can actually download it at the marketplace here. I believe it's also free of charge. You can actually download and take a look at this if necessary. Yeah, so I mean, as a summary here, like I said, today we just introduced what RTI is doing and some of the advancements we are actually looking at to actually try to contribute back to the ROS2 community based on our experience with production systems and stuff like that. So, I mean, right from our CTO office itself, there's a message here for everyone here. We think that a lot of features should be added to ROS2 to make it more powerful, because ROS2, has a great ecosystem with all the different, external things that we could use, and it's so easy to actually build stuff up. But at the moment, we think that it's not taking full advantage of all the DDS features. So if anyone here, has the interest in actually making this happen, or has the knowledge out there to actually collaborate, to actually help to get some of the features inside, we are definitely happy to talk to you to actually how to make a ROS2 a little bit more robust and take advantage of all the features in DDS. Because currently, we think that that's important to actually make this whole ecosystem work. Yep. So. Okay, I think I did finish on time here. I have about 3 minutes for questions if anyone wants to ask anything. Oh, Chris. Oh, I'll be attending a masterclass later.
Very good. I hope that will be very interesting. So didn't have time to test it.
I didn't prepare either.
So I would have one question. I've never checked, but if I wanted to try RTI Connect, what would be the steps and what is the licensing in that case? I just want to try it out.
Sure. We do have a 30-day free trial version, which you can download at our website. I think we do have different licensing things based on whether you're academic research place or commercial company and stuff. But for more questions about that, you can talk to later you can talk to Fanny at the back there.
Okay.
Yeah. But we do have a 30-day trial version that you can try it out.
So there's a 30-day trial version. Okay, perfect.
There is. Yep.
Does anyone have any other questions? Oh, there we go.
Good morning.
Hey, morning.
For ROS2, we use DDS to communicate, right? If a third-party robot going to our system, so got the security problem or not?
Okay, is the third-party robot running DDS or another?
Run the DDS.
Okay.
So, so it can subscribe the topic and publish the topic. But this is the third party, not the system. So what will happen?
Sure. So that's a very good question. Actually, the good thing about DDS here is because it is data-centric, and so everything is based on topics and data type. It doesn't care what operating system you use or what technology or what programming language. It could be Java, C++. DDS will do all the conversion for you. So in DDS, there's this specification called the DDS security specification. So this will enable, even a third-party application, you can actually do things like encryption, access control. So all this is actually done by the DDS specification. You just need to give the configuration file to the third party if he's using DDS. Then both can actually communicate securely. Yep. Access control, encryption, all these are all supported in DDS. And ROS2 also, because it leverages the DDS security.
Okay, thanks.
Yeah. If it's not using DDS, then the answer is a bit more tricky because you need to do some conversion there. So the part that's not running DDS will not be secure. Yeah.
Let's maybe have one more question. No questions? All right. If that's the case, then thank you, Zhi Kai.
Thank you very much.
Let's give Zhi Kai a round of applause.